What is the area of the region in the first quadrant bounded by the graph of y equals e to the 1/2 x and the line x equals 2? So let's quickly draw the situation. So in the first quadrant, y equals e to the x squared, looks like this growing exponential function, and the line x equals 2 is just a vertical line like this. And we need to find the area of the region. Here, let's first label these graphs. So y equals x over 2, and then there's this vertical line at x equals 2. So we need to find the area of the region in the first quadrant bounded by these two graphs. And after drawing, we see that this is the region that we need to find the area of. This region bounded by the first quadrant and these two graphs. So what we need to do is an integral. And the integral that gives us this area is the area under the curve y equals e to the x squared. And we see that we need to calculate this from 0 to 2. Because if we redraw this curve again, the area of that shaded region is just the area under this graph from 0 to 2, from x equals 0 to x equals 2. And we can do that with an integral and setting the bounds. So the area is equal to the integral from an x value of 0 to an x value of 2 of e to the x over 2 dx. Okay, so we can take the integral of e to the x over 2 by finding the antiderivative, meaning what would we take the derivative of to get e over e raised to the x over 2? And the answer is 2 e to the x over 2. We know that the derivative of e to the x is just e to the x, but since we have a chain rule piece up here, this x over 2, we would have to multiply by the derivative of x over 2 when we're taking the derivative of e raised to the x over 2. So if we were taking the derivative of e to the x over 2, we would get 1/2 e raised to the x over 2. But in order to cancel out this 1/2, we can put a 2 in the front. That way, when we take the derivative of 2e to the x over 2, we would get 1/2 times 2e raised to the x over 2. And this would just simplify to e to the x over 2. That way, when we take the derivative of this, we get back to this integrand. So that means the integral of e raised to the x over 2 is 2e raised to the x over 2. And we're going to evaluate this from 0 to 2, because that will give us the area under this curve. So 2 times e raised to the x over 2. So we plug in 2 for x, so e raised to the 2 over 2, that's just 1. And then subtract this 2e raised to the x over 2, but with 0 plugged in. So we'll have 2e raised to the 0 over 2. So that's 0 over 2 is just 0, so 2e raised to the 0. So then 2e minus 2e raised to the 0, but anything raised to the 0th power is just 1, so that means this evaluates to just 2e minus 2. And so the total area under this curve is equal to 2e minus 2, which is the answer choice A.